Hello, geometry students. So one of my favorite things about circles is the fact that you can put other angles and other shapes in them. And today we're going to be talking about the inscribed angle and polygons in circles. So an inscribed angle is an angle whose vertex is on the circle. And the sides actually contain chords of the circle. So for example, this angle right here, angle B or ABC, is an inscribed angle because its vertex is on the circle. Now we need some vocabulary here to help with what we're going to be talking about today. So we need to talk about what an intercepted arc is. An intercepted arc is the arc that lies in the interior of an inscribed angle and has endpoints on the angle. So the arc here, the intercepted arc would be this little arc right here. Okay, and remember we talked about that would be a minor arc in this case because it's two letters, so that would be arc AC. Now the reason that is important is because of the theorem that we're going to be talking about, the inscribed angle theorem. So the inscribed angle theorem says that the measure of an inscribed angle is half the measure of the intercepted arc. So you may remember that the central angle equaled the arc. The inscribed angle is half the arc. Okay? So for example here, if this is the arc and if D is the inscribed angle, okay, angle D would be half the measure of AB. Okay? And C is the central angle and it would be equal to the arc. All right, now let's talk about why that's true. Okay, so I'm going to give you a circle, and you actually did it in your homework if you're in my class already, but you don't even realize that you did. So I'm going to draw this exact same thing, but I'm going to only do this. I'm going to put a diameter right through. And, okay. All right, so I'm going to tell you that this arc is 30 degrees. Now, what I notice is that this segment, and this segment are all radiuses or radii. So remember, I keep telling you, look for those radiuses because they're all equal and I can mark them equal. All right, so then if the arc is 30, then I know that the central angle is 30 because the central angle equals the arc. Now, using what I've learned this year in geometry, this angle and this angle form a linear pair. So I know that that angle has to be 180 minus 30, which gives me 150. Okay, so now I have a 150 degree angle. And now I have this isosceles triangle. If you really think about it, right? So I know that this angle is 150, and I know in an isosceles triangle, because of the isosceles triangle theorem, the base angles are equal, which means that together, the three angles of a triangle add up to 180, that together these two angles have to equal 30. So I take 30, I divide it by 2, and I get 15. So this angle is 15 degrees. Now that's an inscribed angle, and as you can see, if I take its sides and I go up to the circle, the arc that it intercepts, so the intercepted arc is this one, which is 30 degrees, and so the angle is half the length. All right. So let's talk about inscribed angles. So we can have an inscribed angle that actually is the end point of a diameter, like that. We can have an inscribed angle that's a little bit bigger and that doesn't have anything to do with the center. We can have an inscribed angle that's above the center and it's kind of a tiny acute angle. And then this one's the funny one. I didn't draw it in your notes. I want you to draw it. It's a circle that actually has a chord and a tangent. Maybe call it a chord tangent angle. But it's an inscribed angle. This is the inscribed angle. And the arc it's actually intercepting is like this whole thing all the way even into the interior of the angle. And that is also an inscribed angle. All right, well, let's try this. Like, I want to try to find x and y. Okay, so the first thing I want to notice always is my center. So I know that this is a diameter. We know that a diameter from previous lessons cuts the triangle into two semicircles. The circle into two semicircles, and a semicircle has a measure of 180 degrees. So I see that this arc here is 70 degrees, which would mean that this arc here completes the semicircle, so it would have to be 110 degrees. Now, I look at angle x. It is an inscribed angle, so it's got to be half the arc that it intercepts, so it would have to be 55 degrees, which is half of 110. All right, now we got to try to find y, working backwards. If this angle is 50 degrees, it is also an inscribed angle. It intercepts this arc right here, making that arc 100, because the arc is actually double the inscribed angle if the angle's half. All right, and then I have that semicircle on the bottom, which then tells me that y would have to be the rest of 180 degrees, so 80 degrees. And that's how you use the inscribed angle theorem. Now, because of this theorem, that means that 3 other things must also be true, okay? These are called the inscribed angle corollaries. All right, so the first one is that if 2 inscribed angles intercept the exact same arc, then the angles would have to be congruent. So in this case, angle A would be congruent to angle B, but let's see why. Like if this arc is 20 degrees, well, angle A is an inscribed angle, so it would have to be half of it, so it's 10. And then B also got that same intercepted arc, so it would also have to be 10, making them congruent. Now you might want to notice that this kind of looks like an hourglass, and that is actually true. It does often form an hourglass, so it sometimes can be hard to see the inscribed angles. So always remember, an inscribed angle has its vertex on the circle. All right, so here's an example. I've got a 20-degree angle. I see it's inscribed, okay? I also see a center, okay? So I'm going to solve for everything that I can see. I see that this would have to be 40 degrees, which then would give me x to be 20 degrees, because it is also an inscribed angle, and it intercepts the exact same arc. So these two would then be congruent. All right, angle y, how am I going to find that? A little more work's needed. I see that semicircle, so I see this is 60, so this would have to be 180 minus 60, which is 120, okay, which then makes this 60 degrees. All right, corollary 2. This one's kind of challenging sometimes. An inscribed angle in a semicircle is a right angle. So if I know that this is the center of the circle and this is a semicircle, I have to know that this arc that angle is intercepting is 180 degrees, which would make angle B 90 degrees. Okay? Now, I want you to be careful. You aren't if I said inscribe it in a semicircle, this is not an angle inscribed in a semicircle right here. No, that is not. Why? Because the vertex is not on the circle, okay? And this angle right here is not a right angle. So when we're creating it, we have to be really careful to ensure that the endpoints of the angle or the hypotenuse of that right triangle I'm creating is the diameter, okay? All right, so here's an example. I look at this, I see the diameter, so that tells me that this is 180 degrees. So I have an inscribed angle in a semicircle, so angle y has to be 90 degrees. That helps because now I can tell you that this has to be 50 so that the 3 angles of this triangle add to 180. Angle C is an inscribed angle making arc BA or X 100 degrees. So you really have to look deep into these circles, which makes them fun. Okay. All right. Last thing I want to talk about is the corollary number 3. If a quadrilateral, and we're going to talk about this one because it's really cool. If a quadrilateral is inscribed in a circle, that means all 4 vertex of the quadrilateral, the 4-sided figure, are on the circle. Well, then the opposite angles are supplementary. And remember, supplementary means 2 angles, so angle A plus angle C. 2 angles that equal 180 degrees. So A plus C will equal 180, and B plus D will equal 180. Why is that true, Coach Fred? I don't understand. Well, let's just look at angle A. We know that the rotation of an entire circle is 360 degrees. So look at angle A. Angle A intercepts this arc. And angle C intercepts, let me do it in blue, this arc going all the way around to the other side. So together, A and C, they intercept an entire circle, which is 360 degrees. And since they're inscribed, we always take half of that to get their angles. So that's why together they equal 180 degrees. All right, let's look at some examples here. So angle F, it's an inscribed angle. I notice very carefully that this is an inscribed quadrilateral because every one of the 4 vertexes is on the circle. So that means that X has to be supplementary. So that would make it 110 degrees. Y also would be supplementary to angle G would be supplementary to E. So 180 minus 113, I think that gives me 67. So Y would be 67 degrees. All right, looking at number 8, same thing. Supplementary angles are when a quadrilateral is inscribed, meaning all 4 angles are on the circle. So 60 minus 180 is 120, so angle Y is 120. And then 77 and X have to equal 180, so then this would be 103. All right, guys, so that's how the inscribed angle theorem works. Hope it helps. Talk to you soon.